Hello, this is Vardis Santos from NASA JPL. I'm going to give an overview of the coverage project and our efforts to develop a reusable platform for improved, more integrated access to interagency ocean data in support of marine applications for societal benefit. Coverage is a cross-cutting, NASA-led initiative within CEOS, the Committee on Earth Observation Satellites, involving several agencies and GEO programs. It is motivated by the need to address constraints to access and synergistic use of Earth observation, particularly amongst emerging user communities with a need for such environmental information in interdisciplinary applications, including those related to marine ecosystem management. Coverage involves development of a technology platform and reusable open source toolkit providing access to complementary satellite and in situ datasets from distributed sources via value-added data services. It facilitates access to a coherent, curated set of global interagency data products from the 4 ocean virtual constellations: sea surface temperature, ocean color, surface topography, and winds, plus sea surface salinity, at common resolution as a baseline dataset, with the capability to also augment with higher resolution and value-added data products. Utility of the approach is demonstrated in the context of a pilot thematic ecosystem application relating to high seas fisheries and biodiversity in relation to the environment. Coverage has adopted a phased development approach, with governance provided by our advisory board comprised of stakeholder agency representatives and emphasizing community-driven development. Phase B was a 1-year effort involving the development of a prototype capability, with a 1.5-year Phase C activity currently underway, involving further technical enhancements in support of regional ecosystem spin-off applications that we have identified. Here I summarize core satellite data on essential ocean variables included in coverage that span the 4 ocean virtual constellations and that now additionally include sea surface salinity as part of our baseline dataset collections. These are all complementary Level 4 global products from several space agencies that include both near real-time and delayed mode historical data of high value and fit for purpose for a range of applications. Additionally, coverage includes some select value-added satellite datasets in support of our ecosystem thematic application. The first is the GEO-MBON Seascapes Ocean Habitat Classification product, served by NOAA Coastwatch, that is of interest to the marine biodiversity community. The second is a regional Sargassum Floating Algal Index dataset of relevance to our Sargasso Sea application and produced by the University of South Florida. We work closely with USF to implement an interoperable form of this dataset that is now being made available through coverage. Coverage provides generalized support for in situ data of different types, including point, profile, trajectory, time series, and we have demonstrated this capability in the context of oceanographic field campaign collections, such as for SPURS 1 and 2. Additionally, for our thematic ecosystem application, coverage integrates extensive fisheries spatial catch effort series publicly available from the 4 Tuna regional RFMOs, or regional fisheries management organizations, animal telemetry data providing trajectory profile series for multiple species, and AIS categorized fishing vessel movement data from Global Fishing Watch. This slide provides a high-level summary of coverage's distributed data architecture implemented in support of our ecosystem demonstration pilot. The red dots signify the 2 coverage data nodes hosted within JPL Amazon Web Services and UMetSat Copernicus Marine Wikio cloud environments, running our software stack and serving US and European satellite datasets respectively. Additionally, there is dynamic connectivity to in situ data providers at IMOS and CSIRO in Australia and US IOOS, shown as blue dots, serving animal telemetry and other in situ data. Connections to Global Fishing Watch AIS and RFMO catch effort data providers are also shown. Integrated access to these datasets is via coverage data services available on our prototype portal. The coverage website additionally provides descriptive information on the project, a resources area with documentation, pointers to our open source software, tutorial demonstrations, and other project media online via our YouTube channel. There's also a news section on the website listing events and other announcements on coverage activities that is integrated with our project Twitter feed. Incorporation of Google Analytics enables capture of site traffic and the monitoring of usage metrics. Coverage implements a unique web-based tool enabling integrated visualization of satellite and in-situ data of various types. Novel features include tightly synchronized horizontal and vertical views of data and their evolution over time at flexible time intervals. There is also a dataset search capability allowing filtering by spatiotemporal extents, project, platform, sensor, and measurement variable criteria. Online help is available, and the tool also provides a very useful shareable links feature that allows exact reproduction and exchange of detailed views. The coverage viewer is based on JPL's open source Common Mapping Client software framework. On the back end, it supports OGC compliant imagery delivery protocols through coverage on Earth and NASA Gibbs WMTS servers for tiled imagery data processed on an ongoing basis and integrated in the application. There's also visualization client support for external data, serves as imagery via Threads WMS sources. The viewer provides a very well-rounded visualization capability for ocean data and continues to be enhanced to provide interactive subsetting, analytics function support. This short animation highlights some features of the data viewer in relation to in-situ data from IMOS. It shows IMOS animal telemetry data for different species integrated in coverage and overlaid with a range of satellite data products. This allows for interactive exploration of animal movements in relation to dynamic oceanographic features by stepping through time, and flexible exposure and plotting of all variables associated with a given in-situ tagging dataset. In the top left panel, elephant seal movement and profile data are shown in relation to Aviso sea surface height anomalies and Oscar current velocity fields. Top right, we see a Weddell seal track mapped and overlaid on Muir SST with tag environmental profile data plotting adjacent. Bottom left, we see northern fur seal telemetry data on Muir SST, and in the bottom left panel, hawksbill turtle electronic tag data overlaid on globe color chlorophyll fields. Coverage provides analytic service capabilities for included remote sensing data via STAP, the Science Data Analytics Platform, that is an open source Apache Software Foundation incubator project. STAP enables big data science without the need for voluminous data download, offering on-demand processing closer to the source data. A range of built-in parallel computing functions are implemented, with the matchup service capability being developed with additional NASA support. For coverage, STAP is deployed in both our AWS and Wikio cloud environments, providing analytics capabilities for the range of coverage interagency datasets in our data cubes. Interfaces to these STAP instances are programmatically via STAP APIs and Jupyter notebooks. There still remains a need for familiar and more conventional data download and subsetting capabilities to access satellite datasets. For this, we use Threads, that is an established and widely used data server technology, but that is now cloud-enabled and deployed on both our coverage AWS and Wikio nodes. This allows collections of satellite data series maintained as native NetCDF files hosted in these cloud environments to be exposed via a variety of standard services bundled in Threads that users are well accustomed to. Integration of forward data streams on an ongoing basis into coverage threads, STAP, on-Earth imagery and visualization data services is achieved by our generalized data harvester software, soon to be made publicly available open source. Coverage seeks to demonstrate the utility of its approach in the context of thematic regional applications that build upon our current ecosystem prototype. The first is in partnership with the Sargasso Sea Commission in support of its Global Environmental Facility funded project for the Sargasso Sea region relating to conservation of biodiversity in areas beyond national jurisdiction. This is a complex, multifaceted project involving development of an ecosystem diagnostic analysis incorporating environmental data that in turn will support the development of an action plan for stewardship of the Sargasso Sea. Coverage's role as a partner of the Commission is to facilitate access to key satellite data and provide the integrative data system capabilities enabling scientific and policy assessments. A second regional application focusing on the Eastern Tropical Pacific is in partnership with the Inter-American Tropical Tuna Commission, which is a 21-nation intergovernmental regional fisheries management organization responsible for the scientific assessment and management of large pelagic fisheries in the region. There is considerable interest and ongoing work involving the use of ocean remote sensing and model data to inform analyses of species habitat under environmental regime shift, spatial catch forecasting, bycatch mitigation, marine protected area designation. The objective of our collaboration with IATTC is to support their analysis workflows involving the use of satellite data and recreate a published analysis as a proof of concept demonstration initially. Coverage is serving as a cumulative contribution and point of contact on behalf of SEOS to the UN Decade of the Ocean for Sustainable Development. Coverage submitted an ocean shot concept to Ocean Decade US, which is the National Academy of Science committee overseeing the development of UN Decade actions within the United States. Our concept focuses on next-generation data service infrastructures for a more digitally integrated ocean observing system, and it relates to the UN Sustainable Development Goal 14, Life Underwater. In following this Decade US process, we subsequently presented and then published a short article on our ocean shot concept, one of over 100 concepts submitted by the oceanographic community. This recently culminated in the committee publishing a synthesis and recommendations report last April on cross-cutting themes and priority development areas for US contributions to the UN Decade of the Oceans. Coverage is highlighted in this report under the Oceans Data themes. This is an encouraging outcome because it suggests that coverage is resonating as a concept and worthy of continued broader development. Additionally, we also have sought to identify alignments and coordinate with other UN Decade Program elements of relevance, including Digital Twin Oceans, Marine Life 2030, Becky, and IMOS. Finally, coverage places considerable emphasis on community and stakeholder engagement. Over time, we have participated and presented in a range of conferences of relevance, have held several workshops, and are regularly involved in consultations with key stakeholders. This includes SEOS agency partners, advisory board members, and other project collaborators. A couple of publications have also been produced summarizing project efforts. This concludes my presentation, but please view the short video summarizing coverage. Check us out on the web and contact me if there are any questions or interest in collaboration. Thanks for your attention.